I'm Jeff Griffith with Becker Aviation.
And I'm Bobby Sabonik with Eaton Carter.
And we're here today to go over the 64250 Eaton Carter ground fueling single point nozzle. The unique thing about this nozzle is it is compatible with previous generation nozzles 64348, 64349, and 64200, meaning all the attachments, additions, hose end control valve, quick disconnects are all interchangeable from previous nozzles to this new 64250 nozzle.
The 64250 nozzle features robust components and field replaceable wear pads, which makes this an ideal nozzle for heavy use environments. Additionally, it has a floating nose seal which can articulate and allow the nozzle to seal even in worn conditions. So if the aircraft adapter is already starting to wear, this nose seal will acclimate and adjust to the height of a worn adapter. So this is very versatile, very well designed for heavy use environments. Some of the key features with the 64250 nozzle is the solid aluminum adapter ring. This makes it a heavy duty nozzle and can withstand more abuse and more wear locations. Once again, this also has wear pads on both sides of the nozzle and wear handles, wear knob, which makes this a very well protected nozzle. So in heavy use environment, it's very good and very suited for that type of environment.
And the good thing about this nozzle is all these external parts that Bobby mentioned, much more cost efficient to repair and replace these sacrificial parts than the actual body of the nozzle, where we start getting into expensive parts. Now we're going to begin the disassembly process of the 64250 nozzle. First, we're going to remove our dust cap. Utilizing our adapter tool, we're going to open the nozzle. At this point, we have to remove our cotter pin and able to get the poppet off. When we're removing the cotter pin, we just want to make sure that we're being careful not to scratch any of these surfaces. Once the cotter key is removed, we can now easily unscrew the poppet assembly. And close our nozzle. Remove our adapter tool. At this point, we have access to remove the nose seal. The nose seal is just a floating nose seal. It's just held in place. And on the back side, we have a wave washer.
And at this point, if the customer just wanted to replace the nose seal because it's damaged, this would be a great point where they would just stop, replace this, put a new one in there, and then put the new poppet back on.
That's correct. You could replace the nose seal just simply by removing the poppet, removing the nose seal, and inserting the new one.
And if something else is wrong, they would continue with repairing it.
That's correct. Once we have all the screws removed, we can remove our interlock retaining ring, our interlock tab. Another wave washer would sit up underneath that. And this is our internal interlock assembly. Use a small screwdriver to gently lift up on the interlock ring. And here's your interlock ring. Underneath that, you're going to have two Teflon washers. And the purpose of these Teflon washers is so you don't have metal to metal contact when the interlock ring is rotating. Inside that is going to be an O-ring and also a backup ring. Again, you can use a little screwdriver to remove these, being careful not to scratch any of the surfaces where these O-rings may sit. There's the O-ring, and there's the backup ring. At this point, we have the face of the nozzle disassembled, and now we can work on the external components. We'll remove the wear pads and the grips. Now, when removing the grips, you should be able to remove them by hand, but in the event they don't come off easily, this side's coming off pretty easy. We can remove the dust cap. On the top side of the nozzle, we have a blue O-ring. This is going to be our seal for our QD attachment or our hose end control valve. Again, we're going to just gently take a little screwdriver and pull that O-ring out, not to damage any of the sealing surface where the O-ring rides. Below that is going to be our race ring. And there'll be a little gap in that race ring, and that's where the ball bearings ride. Remove that. And next is going to be our cotter pin and our castle nut that holds our crank arm and our linkage assembly together. At this point, we're going to have to work on the cotter pin and get the legs bent back straight so we're able to get the cotter pin removed. Once we got the legs bent straight, take a pair of needle nose pliers, pull the cotter pin out. Now we can take our 7/16 wrench and remove the cotter castle nut. Once the castle nut's removed, now we can take off our pin that holds our linkage and our crank arm together. I find the most easiest way to do this is to remove one of the blue plugs off the side of the body, and that'll give me good access to get in there with an Allen key.
Now, if a customer has another item in that slot, is there another way that they can reach in there and still get to the crank pin?
Absolutely. They can take the short side of the Allen wrench and get in there just like that to remove the pin.
So that just basically gives them two options.
Yes. Coming in from the side is going to take a little bit longer than coming in through the top. You'll notice once I get these two items separated, there will be a washer that goes in between the linkage and the crank arm. There's the screw, and there's the washer that just fell out. that goes in between the linkage and the crank arm. Once these two items are separated, now I'm going to remove the external 3 screws that hold on the operating handle. There's the handle removed with the 3 screws. At this point, I can now take out the crank arm. You'll notice there's a flange bearing on the inside of the crank arm. On the outside, we have a Teflon washer. We have an O-ring and a second Teflon washer and a bearing. On the inside, and you can gently push that bearing out, not to scratch any of the surfaces inside. Just like that. And as everything's put together inside the nozzle, you'll have your 2 bearings, Teflon washer, O-ring, Teflon washer sits in the housing just like that. The last item that we have to remove from the nozzle is the continuity clip and the linkage assembly. Once we have the crank arm out, the linkage assembly is easily removed and is held in place by a pin that just falls out, and you can separate the 2 items. Last component is going to be the continuity clip. You could take a little screwdriver, just bend that leg up just a little bit, and then get in there with a pair of needle nose pliers and pull it out. Now the 64-250 nozzle is completely disassembled. Now we're going to go over some inspection items and some commonly worn items to point out when you have everything disassembled.
Excellent, Jeff. So some of the things that we want to look at when we're inspecting all the parts is you want to look for any areas with damage. I mean, that's usually a key indicator that there's been some sort of impact in that location or has seen some wear or abrasion. So we kind of want to look in those key areas. So anywhere where there's a fastener, you want to go through each one and make sure there's no fatigue or stress cracking in any of these areas, as well as checking where the O-ring glands are. You want to make sure that there's no damage to any of the O-ring glands or anywhere where you have a moving part. You're basically looking for any wear that might be accumulating over time. So if there's any questionable like damage or anything, it's recommended to replace that part to prevent leakage or spills later on in the future. So other areas that we look at would be like the crank itself. You want to look and make sure that there's no scoring or damage. This is a sealing surface here. You want to make sure that there's no excessive wear anywhere else, a stress crack across where the threaded area is. Is there any other locations that you normally see damage?
Yeah, on these 3 thread locations as well, where you secure the outside operating handle, these get over tightened. We have seen stress cracks on the inside wall here.
Yeah, that's a great point. I mean, if you see that, definitely replace it. Anything that's questionable should always be replaced. When you start looking at other parts that see frequent wear, the crank pin is a item that we see excessive wear frequently in. This crank pin supports on the shoulder, supports the linkage. So as it rotates up and down, it frequently wears that area. It is a hardened steel, but that still does wear. So it's really important, it's imperative to inspect that and replace it if you see excessive wear. Other areas that are pretty simple would be any of the sacrificial parts. If there's a crack or any damage, you'd want to replace that. Some of the wear pads, those are great for protecting the nozzle, but it doesn't do too well if it's worn down.
Correct. Yep.
You want to make sure that you replace those. And then some of the other things like the Poppet
Yep, the Poppet. So a couple items you want to inspect here is to make sure that you don't have excessive wobble inside here.
Right.
At that point in time, these Poppets are rebuildable or replaceable.
So what would be the item that would wear in there that would cause it to wobble most commonly?
There's some wear washers down inside there that would need to be replaced.
Okay.
And then also you want to check the beveled edge. Make sure nobody previous to you has went in there with a screwdriver and caused any scrapes or gouges. This is a sealing surface with the no seal when it's in the closed position.
That's an excellent point, because if you do have scratches or scoring, if you go to seal it, it's not going to seal properly against the no seal like you said. And if it's in stowage, it's going to start leaking out. It's going to accumulate fuel on the or puddling around the truck, which is definitely not what we want. So just as you work through it, you want to make sure that all the parts that you're replacing, usually want to replace all the O-rings. You don't want to ever reuse them. Now, do you ever reuse any cotter pins?
You never want to reuse the cotter pins. Once the legs have been folded over one time, you should discard them and utilize a new cotter pin.
And why is that? Why do we? Because doesn't it weaken over time?
It does weaken over time.
Exactly. So we don't want to use that. So as we get ready to reassemble it, we want to make sure that everything is clean, that there's no debris. We want to go through the O-ring glands and definitely double check to make sure there's no scratching, scoring, accumulation of dirt or debris. So that way when everything goes back together again, we have no leakage. Because the worst thing would be to reassemble it and only to find out that it's going to leak again.
Correct.
Yeah.
So this concludes the disassembly and inspection of the 64250 nozzle. Now we're going to prepare to reassemble the nozzle. Okay, now we're going to start the assembly process of the 64250, and we're going to go in the same general order that we took things apart. So the first thing is we're going to put our linkage assembly back together, and you'll notice there's a large hole and a small hole. The large hole is going to be facing up. That's the hole we're going to utilize to put the crank arm and the linkage back together. We're going to line those together. We're going to put our pin in. And I like to hold the pin together just like that, large hole facing up. And in the side of the nozzle, you'll see a groove down in the body. That's where the flat edge is going to drop straight down. And once we get everything aligned, just drop the assembly down in place.
And now that pin that you put in there, it's held in by the body itself?
That's correct. It's encapsulated inside the body of the nozzle, so you don't ever have to worry about that pin falling out on you. All right, so now we got the linkage dropped into place. We're going to go ahead and install our crank arm. And on our crank arm, we mentioned that we had a flange bearing goes on the inside. And just a special reassembly note, if you put the flange bearing in the housing beforehand, you don't have enough room to put the crank arm in place. Doesn't allow enough room. So that flange bearing has to be installed on the crank arm first, and then that allows you enough room to install it in the housing. Now at this point in time, you can see how our crank arm is really loose. I like to go ahead and build out the front side with our other bearing. Once we have that started in place, again, we're going to take just a little screwdriver, make sure we push that bearing all the way down in the housing, being careful not to scratch any of the surfaces. Once we have that sit down, we're going to go ahead and install one of our Teflon washers. Again, walk that around so it sits down in the housing, and we're going to install our O-ring. Now at this point, I can let go of the crank arm and it'll stay in place any position that I want. And that's critical when we go and put our linkage and our crank arm back together. We're going to rotate that around. And again, we have a little washer that goes in between there. So at this time, I'm going to use a little petroleum lubricant. And all this does is hold that washer in place. And again, through the top, I can get everything aligned up. I can set my washer in place. and then carefully bring my linkage up. I'm going to kind of pick up on that and set it on top. Once I think I got everything aligned, then I can take my pin and I can start fastening it together. And again, accessing this top port, I can take my Allen key and I can go ahead and tighten this pin all the way down. And you'll notice that pin had a shoulder on it, so you only want to screw this in as far as it'll go. Once it stops, that's far enough. At this point, we now have our crank arm and our linkage put back together. I can finish building out the outside of the arm. We have our last Teflon washer. And then you'll see on the body of the nozzle you have the closed position and open position. This would simulate the open position. I like to have everything in the closed position. That way I know I have my open close handle in the correct position. We go ahead and install the handle.
And when you're typically installing the handle, and before you insert the screws, you want to add blue Loctite 242.
Yes, that's correct. We've seen in the past that these screws will back off over time.
Yeah, we typically use a medium strength Loctite, so that way it can be easily disassembled later on. Using a high strength or permanent would make it too difficult to disassemble.
And when you're securing all these screws and fasteners, you always want to make sure that you're referencing the service manual and making sure you're getting everything torqued to the proper spec. Everything on these nozzles is torqued in inch-pounds, so a small inch-pound torque wrench would suffice. All right, once we have the outside handle installed, we're going to go ahead and install the castle nut.
And I see that you're holding it with the Allen wrench on the other side. Is that to make sure that it doesn't back out?
That's correct. If the screw pin starts to back out on you, it will not allow sufficient space to be able to insert the cotter pin. And once you have it fully installed, at that point in time, that's when you want to bend over one of the legs and secure the cotter pin.
And for proper installation, it's recommended to review our latest safety bulletins and our service bulletins. It goes into depth explaining how to properly install it, so that way it doesn't interfere with the housing as it's rotating. There's no issues with it, so it's highly recommended to review the safety bulletin.
And you can also tell that it's not installed correctly when you rotate the nozzle. That if there's any binding action going on, you know you have the cotter key installed incorrectly.
Right, and if it's not installed properly, there are risks of the cotter pin becoming dislodged and going into the aircraft, so it's highly recommended to install it properly and ensure that you install it properly.
At this point in the assembly, we're going to install the continuity clip. As you can see, there's two legs on the continuity clip here. These two legs are going to be inserted into the side of the body. And what you can do is take a small pair of needle nose pliers and gently push these two legs together a little bit. And it'll make it so you can secure the clip in the body.
And what's the significance of the continuity clip?
The continuity clip serves as a continuity between the nozzle, the hose end control valve, to the hose when you're hooked up to the aircraft. Once you get everything in place, you're going to swing that over so it rests on the inside ledge of the body of the nozzle, and it'll stay secured in place with your quick disconnect or your hose end control valve. All right, now that we have the continuity properly installed, we're going to go ahead and replace our race ring. And this race ring can go in either direction. There's no upside down or what have you. And this is going to go in the second groove in the body of the nozzle.
And when you're installing it, you want to make sure that you don't damage the O-ring gland during entry.
Just like that. And also when you install the race ring, you want to make sure that the gap in the ring itself is not where the port is where you insert the ball bearings. Next is going to be your O-ring, and that's going to go in the top groove in the very top of the nozzle. Just like that. At this point, I'm going to replace my blue plug that I took out for access to the linkage pin.
Now, before installing it, is there anything that you'd normally put around it to seal it?
I would put a small amount of Teflon tape, not to overdo it because the excess tape may fall into the inside of the nozzle and into the fuel stream.
Right, which has a direct path to the aircraft, so you don't want to put any extra in there.
Get that plug fastened. Next, I'm going to install the wear pads on both sides of the nozzle. Once that one's installed, flip the nozzle over and install the wear pad on that side. Now we have both wear pads installed, and I'm going to flip the nozzle over and I'm going to start building the face of the nozzle. As we took it apart, we had our backup ring goes on the inside groove. And we want that backup ring to sit all the way down on the bottom, and the O-ring is going to sit on top of the backup ring. Just like that. At this point, we have our two Teflon washers. And the purpose of these washers, again, is just to prevent metal-to-metal contact during the rotation of the interlock ring itself. Now on this interlock ring assembly, I like to kind of just get it started. And again, I'm going to push down and turn at the same time, so not to cut the O-ring or have the O-ring roll out of its slot. So I'm going to apply equal pressure down across the interlock ring and rotate at the same time. Just like that. Now at this point in time, it's important that we have this interlock ring rotated in the correct position, because theoretically this interlock ring could be installed in any position inside the body of the nozzle, but we want to be able to position it. So at this point, this would simulate the nozzle being in the closed position, and we know this because we're not able to open the handle. If our interlock rotates, like we're hooked up to an aircraft or bottom load adapter, we are now able to open up the nozzle. And this is illustrated by being able to fully open and close the handle. So for installation purposes, I like to have it in the closed position. We can't open the handle And that way I know when it's fully assembled, we have everything correctly positioned and the nozzle will function perfectly. So at this point, I'm going to install my wave washer, my interlock retaining ring. Again, you'll notice on the interlock assembly, you have two steps. One that goes halfway down and then one that goes all the way down. You want to make sure that the 3 tabs off the side are going in the slots that go all the way down. If you happen to install this ring in the incorrect position, the nozzle will not function correctly, will not be able to be open and closed. So we want to make sure that we are in this position and that ring goes all the way down to the bottom. All right. Now once we have our interlock retaining ring in the correct slots, we're going to assemble the interlock retaining ring with the alignment pin goes in the slot with the alignment pin hole in the side of the body.
And you can tell because the alignment pin hole is smaller than the other holes.
That's correct. So I'm going to come off to the side here. At this point in time, I'm going to secure all of my fasteners. For the purpose of this video, I'm only going to secure 4 of them at this time. Once we have everything fastened, we can come now on the back to the front of the nozzle. And as you can see, we have a little tab stuck out. We could just take a little screwdriver and move that back into place. And you hear the spring pop back. That means you have everything aligned correctly.
So that sound just basically represented it being reset into the the closed position?
That's correct. Yep. So at this point, now we're going to be able to install our nose seal. Our wave washer goes in first. Then our nose seal with our nose seal O-ring. And that's just going to sit down in the inside of the interlock ring and just press down and it just sits there. All right, once we got the retaining ring fully assembled, the last step on putting the nozzle back together is putting the poppet in place. So we're going to grab our adapter tool. We're going to open the nozzle. And you're going to see on the poppet itself, you have 4 slots around the inside of the poppet. And our initial adjustment, we're going to put the poppet on. And we're going to bottom it all the way till it's in the bottom. And you know it's all the way in the bottom when that last slot, you can barely see a little bit of light through it. All right, once we got the poppet installed and we got it all the way down to the last slot where we can see a little bit of light through, this is going to be our starting point for our initial poppet adjustment. And we're going to rotate this counterclockwise 7 slots or 1 3/4 turn. 1, 2, 3, 4, 5, 6, 7. At this point in time, I'm going to install my cotter pin just so the poppet doesn't get jostled and move on me. Once I get that installed, I'm going to close the nozzle, take off my adapter tool. At this point, here's our poppet adjustment gauge, and we have 2 sides to this poppet adjustment gauge. And it's based on serial number of the nozzle. We're working with a serial number that's 2000 and up today, so we're going to use the bottom side of the Poppet adjustment tool. And you could see on the left and right, the one leg is longer than the other. In the center section here, we're going to put on the center Poppet of the nozzle. And what we're going to do is we're going to move this Poppet adjustment tool across the face of the Poppet, and we want one leg to hit and we want the other one to cross. Since they're both crossing with no problem, that means our Poppet is not adjusted correctly, and we're going to have to open that nozzle back up. Take out our cotter pin, and we're going to do one adjustment at a time, one slot. We're going to go clockwise.
And you go clockwise only if you're too high, correct?
That's correct. Yep, if the Poppet's too low, where both sides were hitting, that means you need to go counterclockwise. So at that point in time, I throw my cotter pin back in place, close my Poppet, take my adjustment tool off. Again, I'm going to make sure that I'm using the right side of the go, no-go gauge. And again, run it across in a couple different spots. Looks like I'm still too loose.
So now you're going to go down another quarter turn?
Another quarter turn. Clockwise one more turn. Reinsert the cotter pin. Again, using the correct side of the go, no-go gauge, put it on the top of the Poppet. You can see I'm crossing on one side and I'm hitting on the body of the nozzle on the other. Cross it on one side, hitting on the other. Now we know our Poppet's adjusted correctly. We'll open up the nozzle one more time. We'll make sure we got that cotter pin all the way installed, inserted. And we're going to bend over the leg on the cotter pin. Again, we want to be careful not to scratch any of the surfaces. Close our nozzle. Remove our adapter tool. Make sure the nozzle's in the closed position. Do our go, no-go gauge one more time, just to ensure nothing moved. We're still good to go. Now I'm going to insert my handles and the dust cap. Our dust cap loop is going to go over where one of the handles gets installed underneath of it. Again, these handles, they can be pushed on by hand. If need be, you may use a little rubber mallet. Install our Allen screws. Come to the other side, fasten that Allen head screw all the way down. And that concludes the disassembly, inspection, and reassembly of the 64-250 heavy-duty single-point nozzle.